Today we will see inverse trigonometric functions. So all the trigonometric ratios are related with the right angle triangle, and all the trigonometric ratios are the ratio of the sides of a right angle triangle. So sine function, you know already that sine theta is equals to opposite side, ratio of opposite side and hypotenuse. Today we will see inverse trigonometric functions. So as you know, all the trigonometric ratios are the ratios of the sides of a right angle triangle. So here you know that sine function, like sine of angle theta, is given as the opposite ratio of opposite side and the hypotenuse. So you know that sine takes an angle and gives us the ratio of opposite side and the hypotenuse. So you can see it with the example also. Sine 30, you know, it is 1/2. So now let's see inverse sine function. The symbol for inverse sine is given as sine inverse, and sine inverse takes the ratio of opposite side and hypotenuse and it gives us the angle. So let's see, here you have sine inverse 0.5, or you can say sine inverse half, and that will give you the angle, that is 30 degree. Here a few things that you have to remember is sine inverse is equals to theta. That means it will give you an angle, whereas sine theta is just a number or the ratio of the sides. Now this is also important thing that you have to remember is sine inverse x is not equals to 1 by sine x, because you know that sine inverse x, this value will give you an angle, whereas this will give you a ratio of two sides. So it will be a number. Now let's see the graph of sine x and sine inverse x. Now you know this is the graph of sine x. Now here this graph is within the interval of -2 pi to 2 pi, and here you know for inverse of any function it should be 1 1 and onto. So to make it 1 1 and onto, you can take some intervals. Like first interval you can take as -pi/2 to pi/2. Okay, second you can take pi/2 to 3 pi/2. The same way you can take as -3 pi/2 to -pi/2. So here we will take this interval, that is -pi/2 to pi/2. Now this interval is also known as principal value branch for sine inverse x. Now at this you can see this function is 1 1 and 1 2. So here this is the graph for inverse sine. The graph of inverse sine you can obtain just by taking your x-axis as a y-axis and y-axis as x-axis. So you'll get this. So here this, you know that -pi/2 to pi/2 is the principal value branch for sine inverse x, and you can write your y equals to sine x. Your function y equals to sine x can have the domain from -pi/2 to pi/2, and the range will be from -1 to 1. You can see in this particular graph also the values of sine are always between -1 and 1. The same way you can define y equals to sine inverse x, where your domain is from -1 to 1 and the range will be -pi/2 to pi/2. Now let's see the graph for cos x and cos inverse x. So this is the graph for cos x. Here again you can see I've taken the interval from -pi 2 pi to 2 pi. So here also we will take the interval 0 to pi, which will be the principal branch for cos inverse x. from here to here we have taken. So here you can define your function y as cos inverse x, which is from -1, 1 to 0 to pi. Means the domain will be -1 to 1 and the range will be from 0 to pi. Now let's see the graph of tan x. So these are the graph of tan x and tan inverse x. Here also you can again take the interval, that is -pi/2 to pi/2, as the principal value branch for tan inverse x. Here we will not include these values -pi/2 and pi/2 because at these values you are getting, the value is not defined, because at these particular values the value you get 1/0. So here the function y can be defined as tan inverse x, y equals to tan inverse x, where the domain will be any real number and the range will be from -pi/2 to pi/2, but not including these values. The open interval of -pi/2 to pi/2. Now let's see the graphs of cot inverse x, cosec inverse x, and sec inverse x. So these are the graphs. Now here also you can define the cot inverse x as function from r to 0 to pi. That means your domain will be any real number and the range will be from 0 to pi, open interval of 0 to pi. That will not include 0 and pi. And your function y equals to cosec inverse x will be from r minus -1 to 1, -1, 1 to -pi/2 to pi/2 minus 0. That means for cosec inverse x, the domain can be all the real values except the values from -1 to 1, and the range will be -pi/2 to pi/2 except 0, because at this value your cos inverse doesn't exist. The same way a function y equals to sec inverse x can be defined as r minus -1 to 1. That means the domain will be all the real numbers except -1 to 1, values from -1 to 1, and the range will be 0 to pi except pi/2. Now let's see all the values here. So for sine, you know the domain will be -1 to 1 and the range will be -pi/2 pi/2. And for cos inverse, the domain will be -1 to 1 and the range will be from 0 to pi. The same way for cosec inverse, domain will be all the real numbers except the values from -1 to 1, and the range will be -pi/2 to pi/2 except the value 0. For sec inverse, the domain will be again a real number minus the values from -1 to 1, and the range will be from 0 to pi except pi/2. For tan inverse, the domain will be all the real numbers. For cot also it is all the real numbers, and the range will be -pi/2 to pi/2, and this is the open interval of -pi/2 to pi/2. And for cot, your range will be 0 to pi, open interval of 0 to pi. Now let's see a few examples to make it a little more clear. If you have to find out the principal values of sine inverse -1 minus √3/2, if you have to find out the principal value of sine inverse minus √3/2, so first thing you will, from here sine theta will be minus sine pi/3, because you know that the value √3/2 is at pi/3, so that's why, and the minus sign is there, that's why you can write it as minus sine pi/3. Now you can simply write it as sine minus pi/3. So from here, if you compare, so theta will be minus pi/3. And as you know, the range for sine inverse can be from -pi/2 to pi/2. And here you know that -pi/3 belongs to this interval, so you can say your answer will be -pi/3. Now let's see another example, that is cos inverse minus half. Now again you can see half sin, cos theta is half at pi by 3. So cos theta can be written as minus cos pi by 3. And here you know that like in the previous example you have taken sin as theta as minus pi by 3, but you know the range is not negative for cos. For cos, the range is from 0 to pi. The angles are positive from 0 to pi. Here the angle was coming negative, so here your theta will be pi minus pi by 3. So that will be 2 pi by 3. Now you know, now you can see your 2 pi by 3 belongs to the range 0 to pi. So your answer will be 2 pi by 3. So your answer will be 2 pi by 3. So I hope this is clear.